There's a real battle taking place in energy storage. It's happening right now across the globe, in laboratories, underground bunkers, and inside megafactories. Let's pull back the curtain. It's not just lithium-ion anymore. Beneath the headlines, a war of elements in chemistry is expanding into a technological arms race. From lithium to sodium, magnesium to graphene, calcium to sulfur, dozens of distinct battery chemistries are being engineered into the backbone of tomorrow's world. This video is your high-voltage tour of what's being built right now and what's coming next. Starting with the basics, lithium-ion is the foundation. These are the veterans, found in cell phones, laptops, residential energy storage, grid storage solutions, and in millions of applications across the world. They deliver high energy in tight spaces, but rely on expensive and volatile materials like cobalt and nickel. Over 70% of cobalt comes from the Democratic Republic of Congo, a fragile link in a fragile chain. The new workhorse is lithium iron phosphate. LFP is what China builds with, and increasingly, so is the rest of the world. Thermally stable, 100% cobalt-free, and 30% cheaper. CATL and BYD are installing LFP by the gigawatt. Tesla's Megapack, it runs on LFP, safe, long-lasting, and perfect for the home energy storage or utility-scale battery farm. Next up, there's redox flow batteries, liquid power for the long haul, a battery where power is stored in tanks of flowing electrolyte. Vanadium and iron flow batteries don't degrade, can be cycled forever, and store energy for 12+ hours. U.S. company ESS is building iron flow farms. Invinity's vanadium systems are stabilizing grids across the UK. Big, heavy, unmatched for grid-level durability. Looking into the near future, there's sodium ion, the salt solution. What if we could ditch lithium altogether? Sodium is cheap, it's everywhere, and it works. CATL just launched sodium ion for EVs and home backup. Faradion and Natron are making cold climate systems where lithium struggles. Slightly lower energy, but cheaper, safer, and ready now. Let's talk semi-solid state, a step between worlds. This is the bridge between today's batteries and tomorrow's solid dreams. Gel electrolytes reduce fire risk and squeeze in more energy. 24M Technologies and Wheelion are turning these into home-grade energy packs. Imagine your energy storage system shrinking in half with double the safety and efficiency. That takes us to solid state, a technological revolution. 2x the power, no liquid, no fire. Still a few years from prime time, but Toyota, Solid Power, and QuantumScape are in late-stage testing. For homes, that means compact, ultra-dense, plug-and-forget storage that could last 10 to 15 years without blinking. U.S. residential storage in 2024, 6.4 gigawatt-hours installed, up 47% from 2023. Global grid storage, 100+ gigawatt-hours in 2024, doubling in 2 years. Leading adopters, China, Germany, Australia, California. These aren't just backup systems, they're frontline infrastructure, energy freedom in a box, insurance for your family, or a balancing act for entire continents. The chemistry is complex, but the mission is simple. Power on. Always. Let's look deeper into grid and home storage. The grid doesn't just need more batteries, it needs smarter ones. Today's challenge isn't generating clean energy, it's storing it when the sun isn't shining and the wind isn't blowing. Utilities across the US, China, and the EU are shifting from lithium-ion to new chemistries like LFP, zinc air, sodium-ion, and redox flow. Why? Because they're cheaper, non-flammable, and don't rely on rare earths. CATL, the world's largest battery maker, recently unveiled a 10,000-cycle sodium-ion cell, now being tested in China's first salt-based battery farms. Meanwhile, Zinc8 Energy is developing zinc air systems for long-duration storage with contracts in New York and Canada. In Australia, where grid storage is mission-critical due to solar surges, companies like Redflow are deploying zinc-bromine flow batteries to outlast heat waves and wildfires. In Germany, vanadium flow pilots are being integrated into wind corridors, building resilience into a volatile energy market. And Tesla? Despite its lithium-ion legacy, even they're investing in lithium iron phosphate LFP for megapack expansion because it's stable, affordable, and scalable. Residential storage for your home battery is more than a backup. It's a power trader, a smart node, a defensive weapon in the war for grid independence. BYD's HVS systems now dominate in European households, where tariffs and blackouts are pushing homeowners off-grid. In Germany alone, over 600,000 homes are battery-enabled, many of them tied into VPPs, virtual power plants, where they sell power back to the grid during demand spikes. Tesla's Powerwall 3 is doubling down with built-in solar inverters and seamless V2G compatibility. California, hit by rolling blackouts and peak pricing, is now a hotspot where solar plus storage is not a luxury. It's a rebellion against utility monopolies. Emerging players like Sonnen, Enphase, and EcoFlow are competing with modular lithium iron phosphate and soon sodium ion, making home systems cheaper, safer, and more customizable. Now, with that being said, let's look at some emerging technologies, the disruptors. Solid state is the golden goose, but don't blink, because newer chemistries are closing in. Lithium-sulfur, being tested by Lighten and Scion Power. 5x energy density, no cobalt, ideal for aerospace and defense. Aluminum air. Phinergy's electric buses in India now use aluminum water reactions to drive over 1,000 kilometers with no recharging. Graphene batteries, ultra-fast charging, 3x lifespan. Nanotech Energy is building a U.S. factory to rival China's dominance. Quantum dot batteries, StoreDot and Samsung are experimenting with sub-5-minute charging using nanoscale electron traps. R&D only, but game-changing if viable. Even calcium ion and magnesium ion are being revived in EU labs, aiming for zero lithium futures using abundant earth minerals. Here's the brutal truth. The next energy superpower won't be the country with the most lithium. It'll be the one with the most resilient, diversified, and deployable technologies. We're seeing energy storage morph from a tech solution to an economic weapon, from clean energy's weak link to its greatest strength. China is subsidizing sodium ion and exporting LFP at record pace. The U.S. is countering with tariffs and gigawatt projects in Nevada and North Carolina. The EU, Japan, and Australia are building domestic technological dominance. And in the middle, your home, your car, your grid, the front lines of the energy future. So the next time you hear someone say, "It's just a battery," tell them no. It's an important geopolitical asset of the 21st century. If you enjoyed this video, drop a comment. Let us know what most interests you and what you'd like to hear more about. Keep it electrified.